after both speakers this morning. So over to the speakers.
Thank you, Fiona, for that. And good morning, everyone. I'm just going to share the slides first of all, and then we'll get going. Okay, good morning again. As you can see on the screen in front of you, was myself and two colleagues are involved in this work package as part of Protein I, and we're looking at the technological development to really support supply chain provenance. Fiona introduced my colleague, Professor Ronan McIvor, who will be sharing the presentation piece. And we also are delighted to have our technical expert, Dr. Joe Rafferty from the Faculty of Computing and Engineering at Ulster University. And Joe has done much work in the area of blockchain and distributed ledger technologies, and has been involved in a number of multi-million-pound grants and also proof of concepts in the space of supply chain, blockchain technologies, and other associated Internet of Things applications. So Joe is the real brains behind the technology development here. So we're delighted that Joe is with us as well. So the rundown for this morning is just a little bit of an overview of the Protein I project, then a little bit on Ireland's imports and exports and the supply chains and where we sit at the moment. Some of the challenges with the current supply chains that are out there and the opportunities that exist. We're all aware of COVID. We're all aware, especially in an Irish context, of Brexit. So those are areas that Ronan, Joe and I are involved with policymakers and local government in looking at solutions and developments to help support that. And this morning, we're going to really focus in on the role of distributed ledger technologies as a broad term that includes not only blockchain, but the Internet of Things applications as well. And then we'll take time for some questions and answers at the end. If there are questions and answers that come to your mind during it, I'm sure Fiona won't mind you adding those to the chat menu, and then we can come back to those during the Q&A session. So really, as far as our starting project is, the protein project is really looking at transforming our current food system. And if we're able to feed the rapidly growing global population, we're really looking at planetary health. We're looking at the Ireland of Ireland, and we're looking at ways that we can diversify the foods that currently contribute to the protein intake within the population. So we're delighted that this project, joint funded by Department of Agriculture, Food and Marine, from the Irish government and the Department of Agriculture and the Northern Ireland government, has brought this team together. And really, there's a number of different aspects to it, as you can see in the graphic. We're looking at resilience, we're looking at diversified plant, we're looking at improved human nutrition, and we're really looking at then how we can really change behaviors and psychology of people towards food and that they eat to increase the nutrition in that space. And surrounding that is where we come in our work package, and that's really a smart supply chain technology to try and help that provenance right throughout the supply chain. We're supported in our project by two very capable research associates, Thomas Martin, who is our technical research associate, and Thomas Cowdery, who is working primarily with Ronan and I on the stakeholder engagement piece. So as we talked about in the earlier one, we're looking at developing a smart supply chain digital technology solution. So we're co-designing and developing this for the agri-food sector. There's a lot of work being done in the Internet of Things applications and blockchain technology, and we hear a lot about it, particularly around mining, bitcoins, etc. And sometimes that gives good press, and sometimes that's bad press. We're looking here really at how this technology, when we strip it back, can apply to the agri-food sector. There is a lot of usage in this in telecoms, and if you like, more developed supply chains that are in that technical space. But really, there's a limit of this application in the agri-food sector. But we feel from our research, both secondary research and also primary research, and working with a lot of stakeholders in this space, that there's a lot of opportunity for us to apply this novel technology and address things like security, trust, traceability, and sustainability. There are many traceability softwares out there at the moment, but they don't really have the trust element and that integration piece and security, and we'll come to that later on in the presentation. So in terms of the agri-food supply chain, this project is really focusing on primarily on plant-based proteins such as spring and winter wheat, barley, rye, pea proteins. Those are the type of products that we're looking at. So we're even though there's applications and replications across other products and in animal feed, we're really looking here at human food and looking at developing other varieties of products that we can increase the intake of protein within human consumption and develop that market within the island of Ireland. And the food chain, as you can see, it's really, we're looking at every aspect of that, from the growers right through to the end consumers, and using technology to support that, alongside the other work packages which you may be aware of already, which are about testing and growing different varieties that are resistant to the various issues within our supply chain, and looking at the climate that they're being grown in. So we look at Irish imports. Our agri-food imports in 2021 were 9.7 billion. So we're bringing in almost 26% more than we did in 2012. In terms of the agri-food sector imports by type, you can see on the pie chart to the left, there's a variety of types of food products that we're bringing in there. And obviously these all affect the supply chains, particularly when you've got COVID and you've got Brexit issues as well. And things like cereal and cereal preparation there being 13%, which is a large import of products that we're looking at as part of our process. And to the right hand side in the tabular form there, we can see that the United Kingdom then, in terms of the major import place where we're bringing a lot of that product from, followed by the Netherlands and Germany, and a number of other areas. So we're importing a lot of food, which obviously affects sustainability, carbon footprint, and our accessibility of these foods when there's any supply chain issues. In terms of our cross-border interdependency, there's over 400,000 pigs exported from Ireland for processing in Northern Ireland. There's 400,000 lambs exported from Northern Ireland to Ireland, and there's over 800 million litres of milk exported from Northern Ireland to be processed and then exported from the Republic of Ireland. So a large number of our key agri-food products here are really interdependent. If we look at the Irish food diet, there are 72% of the Irish population regularly consume protein. The majority of these tend to be the fish, milk, chicken, milk, eggs, nuts, the things that we would be very familiar with. There's obviously an increase, as we know, in recent times, of fortified cereal consumption. And we can't really go into any cafe, bar, or garage nowadays without seeing something that has the word protein in your face, with that infused protein products. And 63% of dietary protein is from animal sources, with grains being the most widely consumed plant protein. So it gives us quite a basis to work from in terms of the behaviours and the psychology of the Irish diet. If we look at imports from Irish vegetable, we can see there's 75,000 tonnes of potatoes, 38,500 tonnes of onion, and so on down the list. There's a lot of major vegetables that we're still importing to Ireland. It's interesting when we look at our project because we're looking at plant-based proteins. The plant-based food market in the UK between 20 to 26 in terms of looking forward. From a kind of projection point of view, you can see that plant-based milking is something that is growing exponentially. If we go back 5 years to 2015, it was less than 100, and now it's 385.2 in the left histogram there, and it's due to almost double that in the next 3 years, really, when we take where we are now. And that's the like of oat milk being a major part of that. But you can see in other areas as well, there are growth areas within this plant-based protein. So there is a human, I guess, behavior point of view where people are looking to supplement their current diet with other healthy nutrition products, with plant-based being given a real green light. If we look at the plant-based food market worldwide in billion US dollars, we can see that from where we were in 2020 to where we are today in 2023, it's almost doubled. And if we look at that right up to 2030, there's a projected exponential growth of this food market. So it's certainly something that's under increasing attention and of increasing interest. So it's something of real value to growers in Ireland, and to entrepreneurs and supply chains alike. And obviously retailers are looking at this with a keen interest as well, given the potential market growth. And that kind of links us back to where we are within our supply chains. These are areas that we're looking at, but of course there's major challenges, notwithstanding the Brexit and COVID that we talked about earlier. For example, traceability is a massive challenge. There are many disadvantages of the current solutions. If we're looking at our Amazon product, or we're looking at anything that we buy, there's an issue of trust there in terms of where did the product come from? Is it legitimate? It lacks immutability, and it lacks a lot of security. We can only reflect back to the likes of the horse meat in Tesco burgers and the food safety and quality issues within that. And there's a lack of a robust system to really make sure that is where it needs to be. Of course, we also all have heard about the likes of the sweatshops and how Gap, Next, M&S were unaware of their supply chain beyond their first tier supplier who supplied them. But actually, when you look further down the supply chain, the second tier or third tier supplier, there was some really shameful practices going on there that again was due to a lack of visibility and traceability and technology within that supply chain. Of course, the other side of any technology, as we all know, is that it's all wonderful bringing in technology, but it comes with a cost. And there is 66% of attacks focusing on suppliers' code. I'm sure we're probably all aware in recent times of Royal Mail and their systems being hacked and taken over and held to ransom by some foreign team of hackers who basically are looking lots of money for them to help them get their system back online again. So there's the supply chain attacks are on the rise. So it's important that with this solution that we not only have traceability and trust, but we have security as well, so we can trust and be safe in the details that are there. However, there are many benefits in terms of supply chain if we can grow more product at home, if we can reshore a lot of products that we have been outsourcing and bringing in from various other countries. Then there's obviously a key sustainability opportunity for us with that, and our project around plant-based protein is one area that we can really hope to deliver some real growth, not only nutritionally but sustainably as well. And with the technology that we're building, it won't only track and trace and add security, but we can measure the carbon footprint, we can measure the environmental damage that's been done within the supply chain, so we can measure and monitor that and use analytics to support the reduction. A project that we've been involved in that's linking to this is also looking at using big data and the Internet of Things sensors as a way of trying to reduce the need for waste within the supply chain. Efficiency and productivity is another key area that we can improve, as well as compliance and inventory management. And these are all things that are helping supply chains be more efficient as we move forward. So how does supply chains deal with the huge volume and variety of data? It's true that nowadays, never before has there been more information. We're forever seeing the information overload that we get from emails, from iPhones, from internet. There's data everywhere, and companies are no different. There's an increasing amount of data available. So how do we make sense of that data, and how do we use it to our advantage? The supply chain analytics approach is something that now is coming into play, and a paper recently by myself and my colleagues on this project, we were looking at data sets that are beyond the size of a typical database to capture and store and manage. And the likes of Dell, the likes of Amazon, the likes of Microsoft, now there's a lots of commercial big data tools out there to capture that data and to really make sense of it. And that's again another advantage of this solution that we're developing, is the capturing of the big data and allowing us to make both predictive and prescriptive analytic solutions. So I'm going to show a short video now. So I'm going to click on this before we get into, just to show you a little bit about what blockchain simply is.
Hi, I'm Alexis, your Pharma Ledger virtual host. The technology behind Pharma Ledger is distributed ledger technology, aka blockchain. Blockchain is a buzzword, and in this video, we want to try and demystify it a bit. Blockchain is a network-managed database. The full content of this database is stored in every computer of the network, which can be public, private, or a hybrid network. This model of data distribution is the first feature and benefit of using blockchain: security. To hack and tamper with records would require hacking multiple servers and computers at the same time, making it highly unlikely and very costly. The blockchain network can be programmed to record and track anything of value. All records in a blockchain database are recorded in batches, which are called blocks. All information is stored in a block using encryption, a complex mathematical puzzle which makes each block a unique signature based on its original content. A change of the content would result in a change of the unique signature, making the record invalid. This feature is the second benefit of blockchain, immutability. Differently to a common database, blockchain is designed to assign its blocks to a permanent sequence of records. To do that, every block carries a cryptographic signature of the previous block, organizing the database in a chain of blocks. This special way of recording data is the third feature and benefit of using a blockchain, traceability. Security, immutability, and traceability combined generate more benefits to using a blockchain, such as data provenance, auditability, and privacy. That makes blockchain a great technological advancement, able to transform the way we interact with valuable data. Some even call blockchain the Internet of Value. The Farmer Ledger Consortium aims to lay technology, aka blockchain. Blockchain is a buzzword, and
Okay, so we've hopefully saw most of that video whenever we worked out how to get the slide share working. So we will obviously share the slides afterwards, and you'll be able to see the entire video. But really, when we look back at what blockchain is, and you can see in that short video, it's a distributed database. It's shared among a peer network, and there's a lot of science in behind it. But really, what it does is it verifies every element of the supply chain from the first transaction right through to the last transaction. So it can't be altered with, and it can't be changed at any point. So it's an immutable record of past activity, and it prevents any security issues within the supply chain. So it's a really move forward in terms of traceability software within the industry. So if we move to the next element of this, however, blockchain has been out for some time, and there's a number of I suppose bad press around what blockchain is and how it works. And I suppose it's been very common in society around the likes of Bitcoin and cryptocurrency, but actually it's used in many other ways also. But of course it has its downsides. Since it came out, the transaction speed, for example, each transaction has to be verified by miners, so it makes the process very slow. In terms of scalability, with each transaction, the size of the blockchain increases, and therefore you have to maintain a copy of the complete blockchain. And the energy footprint, as you can see in the bottom right of this picture of people mining, you need a lot of computer intensive work, which leads to a large energy consumption. So while it came out in the market a number of years ago with lots of promise, as part of a distributed ledger technology, it had its downsides. So as part of this project and as part of our knowledge in this space, we've been looking at really developing a new type of distributed ledger technology that overcomes the disadvantages that blockchain has, while still is providing the security, traceability, and immutability that blockchain offers. And with that in mind, we introduce you to the Tangle. The Tangle is really another type of distributed ledger technology where the data structure is replicated across a network of computers. It forms what we call a DAG, which is a directed acyclic graph of blocks, where newer blocks is attached to multiple older ones. It's similar to the traditional blockchain, but it's increased transaction speed. It's got low energy consumption, and it's got no fees. So it works like a blockchain in many ways, but it overcomes many of the disadvantages of what a blockchain has. So in many ways, this actual project is not only implementing supply chain technology, but it's actually implementing leading edge new technology, which really will be really useful for agri-food sector and other sectors in general. So it's quite similar to blockchain. It's more scalable, and it's an Internet of Things. We call it IOTA. It has no transaction fee. So you can see in terms of the picture here that the blockchain blockchain and Bitcoin is a stream, whereas in the Tangle and the IOTA is a much more scalable piece of technology and how it works. So whenever someone records a transaction on the supply chain, we call a digital twin. A copy of that is taken to a database where then we can do some further data analytics, and any issues with security in the supply chain are overcome. I'll pass you to my colleague Ronan now from this slide on.
Okay, Trevor, can you, yeah, okay, I'll just share my screen here. Okay, there we are. So I'm going to continue here to the rest of the presentation. It's really looking at how we've developed the early phase solution design here, which was based on the analysis of requirements in the supply chain in areas such as the farmers, the processors, etc., and an analysis of the technologies available, and where blockchain has been applied also in other food supply chains. So as you can see here from the current slide, our early phase design is going to look at having a mobile app to allow supply chain actors to input data, make transactions, view inventory, etc. So I'll give you the detail of that in a moment and rate that to what the requirements are of these actors in the supply chain. So the intention is to develop a separate mobile app, so customers can use it to scan QR codes, and that will then allow them to view product information. So going back to some of the issues that Trevor talked about there in relation to traceability, etc. We also will have a website that supply chain actors can use to allow to make smart business decisions. So we'll see some of examples around those about what data they can actually use, and also use that as a selling point with consumers, because they can create more information and analyze that and give it to consumers in relation to, for example, traceability. So the website will allow businesses to search for nearby producers and check their quality standards and production volumes. That's one of the aims. So in terms of the technology around the solutions, we're going to use MongoDB, which is a document store, and that will allow quick access to data that doesn't need to be used using the IOTA for verification. And then Trevor's referred to the IOTA Tangle there. So it's an open, feeless, and scalable distributed ledger. So that's the technical solution that we're intending to develop at this stage. So as part of the project, in terms of the research, we've done a lot of stakeholder engagement with consumers, with farmers, and with processors. So we've looked at on the supply chain of wheat, barley, rye, oats, and peas, and we've collaborated with colleagues in other work packages to build up an understanding of developments in these supply chains. And we've also, because of the lack of development in some supply chains, because in terms of wheat, for example, which tend to be used in animal feed rather than for food supply chain, we've actually also engaged with stakeholders in other countries and other regions. So we've done that to identify best-in-class examples and learn from other existing supply chains where crops are being used as food and not feed, which happens with some of the supply chains in an Irish context. Another issue that has arisen from stakeholder engagement is really sharing the data across the supply chain, which tends to be quite commercially sensitive. So we have to deal with that issue as well. That's come up as an issue within supply chains. But in terms of the requirements across farmers and producers, or processors, sorry, and consumers, here's a summary of some of them. I'm not going to consider all of these, but you can see what farmers, when talking directly to farmers, there was a need to save time and administration. How could a solution enhance their marketability of their products? And also, how could bring in an affordable and easy to use technology? And then have the issue of traceability and security. So that's one of the things that we're trying to achieve from our new solution design here. And then some processors, there was some similar requirements around carbon footprinting, and then where the farm is, where the food has come from, and then also the link to labeling and certifications, and also having affordable technologies were straightforward to use, and traceability and security were also issues. And then our discussion with consumers as well around stories around products, but also trying to have verifiable products where, if you know, we found instances where producers or consumers might be fooled by made in certain areas or certain locations, such as made in Italy in terms of pasta. There's ways of having traceability around that to actually prove that through a solution where we can trace right back into the supply chain where the product has come from and where the ingredients have come from. So those are some of the issues around the needs of the supply chain and how we analyze those in order to build some of those requirements into our technology solution. So some of the early insights from our primary research in this project, obviously, based on what I've said, so there is a kind of a knowledge and capability deficit in the area of digitization, the use of technology, and also process optimization. So when we talked about optimization, we're talking about issues around speeding up items moving through the supply chain, also removing the need for manual interventions or paperwork and within that. So there is a need for more education and awareness of the potential supports in this area. And we found that there is some investment in strengthening the agri-food sector around policy supports, digitization and sustainability, etc. But there is really greater potential to enhance competitiveness in this sector through process optimization, traceability, and supply chain integration and provenance. So those are some of the key issues that, and some of the areas that we're trying to focus on within our technical solution here. So before going through what we found in terms of the supply chain that we've looked at within an Irish context, here's a sample example from Internet of Things that has used blockchain technology in the supply chain for halal food. And you can see some of the examples here, the advantages and benefits of doing this. You know, if looking at the regulatory bodies and the raw materials, producers, they can get certificate of origin through this technology, and that can be verifiable, and that can go through right through to the end consumer who can get a QR code and interrogate and access the data right across the supply chain around these key issues. And that's one of the things that we're trying to develop from this application in our own context around this project. Okay, so but that's a sample of an area in the halal area, but give you the potential of these technologies to actually bring those benefits to bear. But in terms of our analysis, in terms of the food journey that we've looked at, so we found that the steps through our process mapping and our value chain analysis, with the farm to the collection center, the processor, the customer to the retailer, distribution. So A, B, C, D, E there. So there is potential. I'll show you some examples of how we can make a link here through the technology solution. So we think about process A, from the farm to the collection center. The current systems tend to be repetitive, and the same information tends to be written on dockets with every shipment. But one of the things that potentially the benefits of moving towards a technology solution is completely paperless, and information can be automatically generated, and the user only needs to select product and quantity. So that's one process A. The other process between the collection center and the processor. So the current system allows distributors to manipulate the products and products' origin and impact food security, and that can be detrimental, as we've seen in the Tesco horse meat scandal. But the future system through maybe a blockchain solution is far more trustworthy, where the distributor is unable to sell the product that hasn't been received, and importantly that they can check the origin and quality standards of produce, even if it has been mixed with another product. So that's the potential with a technical solution in that area. And then from process C and D, from the processor to the retailer, at the moment there's currently a lack of assurance that documentation received is trustworthy. And another problem is a product can have many ingredients, making tracing their origin quite difficult. So the future solution would be have a known origin of all produce down to the day of harvest and in what field the produce was grown. And that's really down to a high level of detail in terms of the data there. And then we can able to see the production values of each ingredient, and then once the retailer can see that, they can make smart decisions around how much the product the producer makes and other elements around that as well. Okay, and then process E from the retailer to the customer. So in this case, the current system is traceability is quite challenging. The only a product can come directly from the source. Customers only can get generic traceability, such as made in Ireland or British beef. So we don't have a high level of detail or can interrogate the data around that. Whereas moving to this new system is extremely high level of more traceability, where information will be need to be held to protect business privacy as well. And the customer can scan a QR code on the product to see all available information. For example, the carbon footprint, the quality standards, pesticide, herbicide use, etc. Okay, so we found that that's something that consumers could benefit, but also other entities within the supply chain as well. And then just taking an example here of a farmer, when we do the hypothetical example here, John, that we pulled out from our analysis of the needs of farmers. So some of the responsibilities, machinery maintenance, growing crops, etc. And tends to need accounting and booking systems and a farm management system. Well, at the moment, a lot of farmers are maybe have weaknesses in this area. So where that leads to challenges, they can't find a local market for crops, or being undercut by imported grains. Okay, so if we look at some of the mapping we've done here around this, maybe the potential benefits across the journey and the supply chain, and this can be assisted through blockchain. We'll see the benefits of this in a moment. But if you look at right through from planting, growing, after harvest, and then selling, so there are a number of user actions across this this chain and journey. All right, and there are a number of touch points, and of course there's a number of pain points as well. So we've looked at where blockchain can be applied here, and also where we can actually try and reduce the pain points for the farmer and increase the benefits from them. And what that can do, if we go to the selling process, they can look and creating a transaction, select the buyer, or create the QR code. But going through the analysis, they can come up with benefits around yields, kilogram per acre, etc. And that's looking through the chain. And if we can design a blockchain solution to actually hit a lot of these pain points and reduce them for John and the farmer context. So if we look at the benefits from a data analysis perspective, for example, the system can automatically calculate production values such as yields, kilogram per acre or kilogram per field, and then around fertilizer and pesticide consumption per acre and field. And then consumer trust, we've data around carbon footprint and fertilizer uses, so that can be passed on to the consumers and other parts of the supply chain. And then we have inventory management, which the system can track the farmer's current inventory, allow for better management and planning. And then in terms of marketing, this will allow registered buyers to be able to search for products in the system and return a list of local producers. And that will allow interested local business to get in contact with a farmer such as John and bringing the market to him. And Trevor, I'll just return you to the conclusion here. You want to conclude there?
If you just leave that slide up, Ronan, and I'll work from there.
Okay.
Yeah, so as I say, thank you for listening this morning. Obviously, we went through that in a very kind of a robust and quick way in some ways, but it's a whistle-stop tour. But hopefully you get an understanding that actually in terms of the issues and challenges within the current supply chains, that the distributed ledger technologies are something that's of real value and can add real efficiency and help with cost and profitability for stakeholders, as well as sustainability, security and trust. And we had looked as a summary at the likes of blockchain initially and found that it had a lot of downsides to it, and that's why we've come up with the 2.0 version, which is really the IOTA triangle as our way forward to move that. So we feel it will reduce repetitive data, it will tackle fraud, it will increase trust, it will help with carbon footprint and food provenance, it will support the local arable and horticultural sector and allow consumers with that knowledge, with all that data that's out there, to make better choices. And ultimately it means that we will encourage our local population and hopefully beyond to consume more locally grown protein plants. So that's kind of the ambition of our project. As you could see in the earlier slides, there's a real marketing opportunity and business opportunity there for plant-based proteins, not only from a business point of view, but also from a human nutrition point of view. So thank you for listening, and we'll pass back now to the chair to coordinate any questions that you may have. Thank you.
Thank you very much, Trevor, and thank you to Ronan. And I also thank Thomas and Joe, who've also joined as panelists now for our questions. So we have 2 questions in. If there are any further questions, please type them now, because as we start answering the first question. So the first question is from James O'Reilly, and it says, thanks for an interesting webinar, interesting work on scalability. Regarding this, when data is copied to database for analysis, is this equivalent to offline analysis? Anyone want to take that?
Sorry, we'll probably, Joe, did you hear that question okay?
It's in the Q&A. It's the first question in the Q&A.
Didn't hear it, but I'll just check the Q&A. Interesting webinar regarding work on scalability and data is copied to database for analysis is equivalent to offline analysis. Depends how we use it on the extra database, but yes, it would be offline analysis and then verified against the source of truth in the DAG and the distributed ledger, if that makes sense, Seamus.
Thanks very much, Joe. And second question from an anonymous attendee, will the consumer be able to understand this information in a logical sense? That is, understand that pesticide use is necessary and not always a bad thing, that zero is not necessarily needful or helpful.
That's difficult to answer. Depends on the consumer. We can have the messaging as clear as we possibly can put out there, but you know, we can only educate to a point. And you know, we've got a QR code, we've got a scannable application, we've got a label, and that's as far as we can go. If the consumer wants to educate themselves, they probably will do. If the consumer has got fear stoked in them from reading various news sources, you know, there's opinions that we won't be able to change.
Thanks, Joe. And the third question and final question here this morning is from Helen, who asks, from the stakeholder engagement, which group of stakeholders are most interested and are likely to drive uptake? Which is a very interesting talk.
Well, I'll start with this, and if any of my colleagues want to come in on the back of that, Fiona. In reality, with any, we had an interesting discussion yesterday in another business meeting, and really we were looking at stakeholders, and we're looking at customer segments. And reality is that a lot of this is driven from the retailer. The retailer quite often have the power, and if the retailer are really requesting their suppliers or further down the supply chain to have this information, to have this traceability, then it's something that will be done. Obviously, from a solution point of view, we're looking at not only developing a solution of traceability, but we're also looking at ways of making farming more affordable. We're looking at diversification, we're looking at efficiency. So we're looking to provide a number of solutions, not just a technical solution at each stage of the supply chain, but it's the retailers mainly that are driving this, but also policy makers as well, and government, particularly with a number of the security issues out there, particularly with a lot of the scams that are going on in terms of lack of traceability. So it's probably co-creation in terms of the answer to that. There's a number of bodies that are really interested in this, for differing reasons, but it's largely government and retail that would be driving the uptake, and then obviously the other ones will follow in behind that.
Thank you very much, Trevor. And that's our last question. I really enjoyed the talk this morning. I can see the benefits of that, particularly in All Ireland context as well, in terms of cross-border movement of goods. I think there's huge potential. I want to thank Ronan and Trevor for giving the talk this morning, and Joe and Thomas for also coming in to help with questions. It's a very important and very exciting aspect of the Protein Eye project. Thank you to the viewers who joined us this morning on the webinar, and thanks to Aoife, who is the manager of Protein Eye, who keeps us all in check, for organising this talk as well. It is recorded, and we will look to the future to how we might disseminate those recordings. So thank you very much.